and share and subscribe and like.
We will see how to find a solution of non-homogeneous differential equations. This type of equations contains again complementary functions and particular integral. Complementary functions we have seen in the previous video how to find a complementary function. If we compare this factor with uh, d minus m d dash minus a, we get m is equal to 1 and a is equal to 2. So one factor of this complementary function will be e raised to ax, that is 2x into phi 1 of y plus x. Again, if we compare this with this factor, we have m is equal to 1 and a is equal to 3. So the second factor is e raised to 3x into phi 2 of y plus x. This is the complementary function. And the particular integral. To find the particular integral, method is similar to 1 divided by, write down this factor, d minus d dash minus 2 into d minus d dash minus 3 operating on e raised to 3x minus 2y. Compare this factor with ax plus by. We have a is equal to 3, b is equal to minus 2. Then put d is equal to a, that is 3 here in this case, and d dash is equal to b. So d dash equal to minus 2 in this problem, and directly substitution will give us particular integral. So a is equal to d is equal to 3 minus minus plus 2 minus 2 into 3 minus plus 2 minus 3 minus 3 into e raised to 3x minus 2y plus 3 minus 3 plus 2 minus 2. So 3 into 2 is a 6, 1 divided by 6 into e raised to 3x minus 2y. Hence, the complete solution consists of two parts as we have discussed. Z is equal to complementary function plus particular integral. Then complementary function is e raised to 2x phi 1 of y plus x plus e raised to 3x into phi 2 of y plus x plus particular integral 1 divided by 6 into e raised to 3x minus 2y. This is the solution of this equation. Okay, now consider one more example of this type. Suppose that we have d plus 1 into d plus d dash minus 1 z is equal to sine of x plus 2y. Again we compare this d minus md dash minus a. Comparison gives me 0. Here is a we do not have d dash term. So a is equal to minus 1. Then the factor is e raised to ax, that is e raised to minus x phi 1 of y plus 0 x. Compare this with this factor. Then we have m is equal to minus 1, a is equal to 1. So additional factor is e raised to x into phi 2 of y plus x. This is our complementary function. Within a one step we get a solution, complementary function. Now particular integral is equal to 1 divided by d plus 1 into d plus d dash minus 1 operating on sine of x plus 2y. Now to operate this operator, we know that we require the term d square, d into d dash and d dash square. Therefore, first we multiply this term by these two factors, d square plus d into d dash minus d plus d plus d dash minus 1, and then let us operate this on x plus 2y. Plus d minus d will get cancelled, and we have here 1 divided by d square plus d into d dash plus d dash minus 1 into sine of x plus 2y. If we compare this angle with ax plus by, we have a is equal to 1, b is equal to 2. Then we put d square is equal to minus a square is equal to minus 1 square is equal to 1. D into d dash is equal to minus ab is equal to minus 1 into 2 is equal to minus 2. So let us put this value in this particular integral. This will be 1 divided by d square. D square we have 1 plus d into d dash we have minus 2 plus d dash minus 1 into sine of x plus 2y. Okay, so plus 1 minus 1 will get cancelled and we have 1 divided by d dash minus 2 into sine of x plus 2y. Now again we have this factor, so we have minus sign here, minus 1, here is not plus 1, minus 1. So minus 1 and minus 2, this look at this minus minus, we get here minus 4, right? Now we multiply and divide by d dash plus 4 divided by d dash plus 4 into d dash minus 4 sine of x plus 2y. Okay, this is equal to d dash plus 4 and in the denominator we have d dash square minus 16 sine of x plus 2y. D dash square equal to minus b square equal to minus 2 square, minus 2 square equal to minus 4. Then this term will be d dash plus 4 divided by minus 4 minus 16 sine of x plus 2y, and this is minus 20. Okay, so let us remove some part to get this particular integral. Particular integral, then this will be particular integral is equal to minus 1 divided by 20 into d dash plus 4 operating on sine of x plus 2y equal to d dash means derivative with respect to 2y minus 1 divided by 20 into derivative of sine, that is cos of x plus 2y into derivative with respect to 2y, that is a 2 plus 4 into sine of x plus 2y. Okay, taking 2 common, if we take 2 common we have minus 1 divided by 10 into cos of x plus 2y plus 2 into sine of x plus 2y. This is particular integral. Then the complete solution of this equation, z is equal to complementary function is e raised to minus x phi 1 of y plus e raised to x phi 2 of y plus x minus 1 divided by 10 into cos of x plus 2y plus 2 into sine of x plus 2y. So this is the complete solution of this differential equation.
Hello guys, thank you for watching video.